What's up, BTBG family? Welcome back to another one. I am so excited today. We're going to be doing our episode 2 of the Foundation series, where we're talking about everything when it comes to the soil, watering, and all the baseline things that you need to know to grow the best and strongest produce that you can grow. As you can see, we're in front of our big tomato bush today. I love my tomato babies. They're more like tomato adults at this point. But let's jump right into it. We're not going to waste any time because it is getting hot by the second out here. I'm already sweating down my back. So the first question, uh-oh, I think I lost my pen. Oh, there it is. Got it. All right, the first question is, what is soil anyway? Well, soil, in its simplest form, is the loose top layer of the Earth's surface where plants grow. Now, my purpose in this series is to break these things down in their simplest form so that you guys can really understand what type of soil you have, what your soil taxonomy is in your particular geography, so that you can grow the best possible plants that you can grow based on your soil type and based on the particular plant's preferences in soil conditions. So soil science is an entire academic field on its own. You know, people go to college for several years, get their PhDs in soil science. My purpose here is just to make it simple, digestible, and easily understandable for you so that you can go out there and get some plants in the ground. Okay, let's keep going. Is a complex mixture of weathered rock minerals, organic matter, water, and air that supports terrestrial ecosystems in agriculture. So I just said the word soil taxonomy. What is soil taxonomy? Soil taxonomy is defined by a few key diagnostic properties or dominant soil forming processes that result in broad differences among soil. Those properties are climate, so how hot it gets, how cold it gets, how much it rains, how much wind there is. You have the organisms, so the micro and macro fauna. You have the bugs, the larger animals, the squirrels, the deer, what have you. The relief or landscape. Whenever you have different landscapes, that you are on the side of a mountain or a hill, as the rain is coming down, it's going to be propagating or percolating down that hill and causing different erosion patterns for those different rock minerals and creating a different type of soil. And then you have parent material. Parent material, if you have a material that's higher in limestone or calcium, then that's going to create more of a chalky soil, so that also plays a role. And then time. Time is the big one, because these are geological processes. You're going to have a very different type of soil, different taxonomy of soil for an environment that is very young. Say maybe, a volcano just erupted, 20 years ago. That soil taxonomy is going to be completely different from an old growth forest. So that being said, let's go down and list the soil taxonomies. I'm going to be putting the different soil taxonomies with their pictures and some different details for them right here. So feel free to pause the video and read and kind of observe the pictures so you can really kind of see what those soil taxonomies look like and what their different properties are. I'm going to be pausing a little bit so you can read. First one is alpha soil. Next one is andesol. Then there's aridisol. Next is entisol. Gelisol. Then histisol. Inceptisol. mollisol, oxisol, spodosol, ultisol, and finally vertisol. So there are 12 taxonomies worldwide for soil. And I have to make sure that I distinguish these, as these are soil taxonomies, not types of soil. Soil taxonomies specifically are talking about the environmental conditions, the geology, the geography, the climate, the organisms, the parent material, all those things that play a part in the soil forming processes. Now, I try to be very specific and distinct when I talk about the difference between taxonomy and soil. Taxonomy represents, or is defined by, the soil forming processes. So all the climate, the organisms, the landscape, the parent material, the time, the geography, and what's there natively. The types of soil is what arise out of that taxonomy. You know, you're going to have, say you have iridisol. Iridisol is more of a desert type of soil. You know, it's going to be more sandy or silty depending on where it is, versus you have andesol, which is more of a volcanic environment, you know. So in that area, you're going to have, you know, more, I don't know, probably more chalk, and also more silt, because volcanic ash, volcanic material is, you know, once it sets for a long enough time, becomes very, very fertile. You can check out Hawaii, you know, once they get new islands, stuff starts growing like crazy. Okay, so let's move on to the types of soil. So type of soil, you have sand. This is well draining and loose. Of course, you have lower nutrients, lower nutrient availability in sand. You have clay, which is poor draining, but it's dense. It's poor draining and dense, but it also has a higher baseline nutrient density. You have silt, which is moderately draining. It's characterized by its very soft and silky texture. This is going to have more of a balanced nutrients, but of course silt is something you're going to find more along riverbanks. For example, the Nile River. It's why the ancient Egyptians farmed that area around the Nile River, while they were able to create such a huge civilization, because they had access to very strong, rich, silty soil. And then we have loam, which is good drainage. It's a mix of sand, clay, and silt. And it has high nutrient availability. And loam is probably the gold standard of what everybody wants, because it is good for most crops. And then you have chalk. Chalk is excellently draining. It's rich in lime and calcium, but the nutrients are often locked up, you know, because of you know, how chalky and dry that soil ends up becoming, because of how excellent the drainage is. So a lot of times you'll end up having to add a lot of organic material to help bacteria to come in to help break down a lot of that, you know, locked up nutrients. And then finally we have peat. This is a material that soaks up water really, really well. It holds water really well. And then it has a lot of organic material, and then high nutrient availability. It's also really good, just like loam, but the difference is that it soaks up water like a sponge, so you have to be very careful to not overwater this particular type of soil. Now let's talk about the stuff that matters to you. What can you grow in this different soil? And like I said, I'm also, what I'm going to do real quick for a second is, if I haven't already, I'm going to add a map right now to show you the United States and all the soil taxonomies across the country, so you can kind of see where you are and what your particular type of native soil would be. Here in the PNW in Vancouver, Washington specifically, we have a mixture of alpha soil, andisol, intisol, and inceptisol. Alpha soil being forest with more clay underneath. Andisol is more volcanic. Of course, we have Mount St. Helens, we have Mount Rainier, and other volcanoes around the area. And then we have Intisol. Intisol is a younger taxonomy that doesn't have clearly distinguished horizon lines within the soil, and the horizons basically are the different layers of sediment that form over time that you can show you what has happened over time for that particular environment. And then you have Inceptisol, which is also young, but it does have defined, distinguished horizon lines. So that's kind of what we have here in the PNW. It's very, very dynamic, like everything up here. Like so I'm gonna show you the map so that maybe you can check it out. Please feel free to pause the video so you can locate where you are. You can actually see what your native soil taxonomy is. Editing Daniel here. I didn't get a chance to really map properly the soil taxonomies, the most common types of soil you'll find in that taxonomy. So I'm doing that right now. On the screen, you'll see a soil taxonomy to soil type mapping, where say the most common types of soil found in the particular taxonomy, as well as the some examples of the different locations where that particular soil type will be. So you'll be able to look at the map, map where you are on that map, figure out what your soil taxonomy is, and then you'll be able to derive what is your most commonly found soil type in your particular geography. Thanks. Take it easy. Okay, so we talked about taxonomy. We talked about soil type. Now we're going to talk about the types of things that you can grow, the best things to grow for your particular native type of soil. So the first one here is sandy soil. Sandy soil, you can grow carrots in really well. Like I said, it's a looser soil. It's very well draining, so carrots love it, radishes love it, sweet potatoes love sandy soil. And of course, like I said, sweet potato is a tropical, quote unquote, vegetable. It's a tuber, of course, but it doesn't grow like normal potatoes. It grows from vines. Arguably normal potatoes are vines, but this is much more viney than a normal potato. So sandy soil, you have carrots, radishes, sweet potatoes, things like that. Love that type of soil. Then you have clay. We have a lot of clay here. Of course, I just told you the different taxonomies, but kind of the default here up in the PNW, at least in Vancouver, Washington, is more of a clay soil. Some people hate clay soil. I love clay soil. You get a lot of benefits. You just really have to know how to work it. Add enough organic material at your most like you're supposed to. Don't overwater, because that clay is going to hold on to every bit of that water, which is good, but it can also hurt your plants. So clay soil is good for growing broccoli, cabbage, and lettuce. And you have silty soil, which is good for spinach, tomatoes, and cucumbers. And then you have loamy soil, and that's what I was talking about. Loam is kind of the gold standard because you can grow almost any crop in loam. Then of course you have peaty soil, which is a little more acidic. So different plants that like lower pH really enjoy these type of soils. So like blueberries, cranberries, of course blueberries kind of like what down to probably 4, 3.5, 4. On the pH scale, chalky, alkaline loving or tolerant plants, spinach, beets, asparagus for your asparagus lovers. And yeah, I'm gonna show you an example from my soil. So this here, I just want to show you the difference. This is dirt. You know, this isn't completely dried out, but this is dirt. You know, there's no life in this. It's dried out. There's nothing happening. You know, it's just dry, basic dirt. This is soil. Now I got this sample from another part of my garden over here, where I have more access to more of the subsoil, because the subsoil is really where I work. If you look up the definition, you know, they'll say, oh, subsoil is what, you know, gives the plant structure to hold on to, and you know, holds on to water, but it doesn't have very much nutrient content. That's not true. That is completely dependent on how you are gardening. I garden with the technique called in-ground composting or trench composting, and I dig 1 to 1.5 foot trenches, and I put down some very, like I said, raw compost, food scraps, and I allow for all that stuff to break down in the ground, where the worms are, where the nematodes are, where the bacteria and fungi already are, and that creates really, really rich subsoil like this. You can see, if I hold close, you can see there's a number of aggregates, and aggregates are basically little bunches of nutrients, as well as colonies of microorganisms that end up, you know, operating within the nitrogen cycle, the nutrient cycling of our garden. I used to garden a lot in buckets and containers, because like I said, we're still renting, you know, and I, you know, was like, okay, maybe we're not going to be here long enough to where I can actually get something like this established. But I said, you know what, I'm going to go ahead and get it, you know, I'm going to go ahead and start it. I'm going to go ahead and do it where I got it. Because you know, this is something that I love doing. I've never been able to get the level of ecosystem development, soil development that I have always wanted within containers. That's why I said, you know what, I'm gonna just start gardening way back here in the back. This whole area back here was just weeds when we first got here. It was weeds, it was clover, it was just a bunch of stuff. And I said, I'm gonna transform it, and that's what I did. Okay, so this is the other part. So as you saw, we have dirt, which is lifeless, dry, you know, ultimately soil, quote unquote, but it's dirt now because there's no life in it. Then we have soil, which has all the organics, it can hold on to moisture and everything else. And then we have topsoil. Now this is what my topsoil down here looks like. You can see all the organic material, all the leaf matter, a few wood chips, as you know, different mulch that I've used over the past. It's very broken down, and it's ready for the bugs and the bacteria and fungi to break it down into more accessible stuff like this. So, like I said before, we're gardeners. I don't expect that, you know, just like me, you're gonna be going into your backyard and digging a hole directly into the native soil to try and plant some vegetables. You're probably gonna go to the store. You're probably gonna get a few bags of in-ground soil to start your beds. You're probably going to, you know, get some sort of amendment. You know, the purpose of this is to understand the baseline default characteristics of your subsoil more than your topsoil. Because whenever you put your plants down, you're going to be putting your tomatoes down into the ground. More than likely, you're going to be planting them, you know, 6 inches, if not, you know, 8 or 9 inches down at which point you will be accessing subsoil. And then that subsoil is going to be those different characteristics of your specific geographic taxonomy. That being said, we're going to stop here. I really, really appreciate you guys for joining. Thank you so much. If you have any more questions about this particular subject, if you have any comments, concerns, criticisms, if you want to correct me on something, please do. You know, what I'm trying to do is make it simple, easily digestible, and more than anything, easily applicable. Okay, so that being said, you guys have a great day. That's the end of the Foundation Series Episode 2. Stay tuned for Episode 3, where we're going to be talking about the soil food web. Now that one is going to be fun. BTBG, I've been Daniel. I said that wrong. This has been BTBG. I'm Daniel. Have a great one. Never stop gardening. We'll see you in the next one. Later.